European Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on isotonic, hypotonic, and hypertonic conditions. In our last lesson, we learned about osmosis. Osmosis is the movement of water molecules across a semi-permeable membrane from an area of higher concentration to an area of lower concentration. We learned about some of the similarities between osmosis and diffusion and discussed using potatoes in an experiment to demonstrate the occurrence of osmosis. Today, we are going to learn about isotonic, hypotonic, and hypertonic conditions. We will define each solution and discuss how they are related to osmosis. Are you ready to begin, students? Let us start with a brief review. In our last lesson, we discussed solutions, solutes, and solvents. A solution is a homogeneous mixture of two or more substances. Students, can you recall the definition of a solute and a solvent? Please take a few minutes to write down your definitions.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I hope you were able to remember what we learned in our last lesson. A solute is a chemical that is dissolved in a solvent. A solvent is a liquid in which a solute dissolves. The terms isotonic, hypotonic, and hypertonic are usually used when referring to cells of living organisms. However, these terms can generally be used to compare the concentration of a solute in two solutions. The definition of the three terms are as follows. If the concentration of the solutions on both sides of a cell membrane are the same, they are isotonic. If the concentration of the solution on the outside of the cell membrane is higher than the concentration of the solution inside the cell, it is hypertonic. If the concentration of the solution on the outside of the cell membrane is lower than the concentration of the solution inside the cell, it is hypotonic. Now, we are going to look at some of the characteristics for each solution. The concentration of isotonic solutions inside cells is equal to that of the outside solution. There is no overall movement of water across the semi-permeable membrane, and the cell is at equilibrium. In hypotonic solutions, the greater concentration of the solution is on the inside of the cell rather than the outside. The water potential is low and osmotic potential is high inside the cell. There is overall movement of water into the cell from the solution across the semi-permeable membrane. In hypertonic solutions, there is a greater concentration of solute outside the cell rather than inside. The water potential is higher and the osmotic potential is lower inside the cell. There is overall movement of water from the cell to the solution across the semi-permeable membrane. If cells are in hypotonic solution, the higher water concentration in the solution will diffuse into the cells, swelling and possibly bursting them. If cells are in hypertonic solution, the higher water concentration inside the cells will diffuse out, causing the cells to shrink. If cells are in isotonic solution, the water concentration in the cells will be the same as in the solution, so there will be no overall movement of water into or out of the cells, and no change will occur. Students, how are cells able to keep from bursting or shrinking? For our next activity, discuss this question with a partner.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Did you all have a chance to share your ideas? Cells are able to keep from bursting or shrinking by maintaining even levels of solution concentration. When equal amounts of water are able to enter and leave the cell through the selectively permeable membrane, the cell can maintain its shape. This is called equilibrium. As you can see from the diagram, there is a difference between cells in isotonic, hypotonic, and hypertonic solutions. The cells in the isotonic solution look to be the correct shape. The cells in the hypertonic solution look small and shriveled. In hypotonic solution, water enters the cell through osmosis. This causes the cell to swell, and in the case of isolated animal cells, eventually burst. Students, we have time for one last activity before we end our lesson for today. You will see 3 simple diagrams of cells. The solutions inside and outside the cell are given. State whether the cell is in an isotonic, hypertonic, and hypotonic solution. Draw arrows to show the water movement into or out of each cell.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? Let us look at the correct answers together. The first cell is in a hypotonic solution, and water moves into the cell by osmosis. The second cell is in a hypertonic solution, and water moves out of the cell by osmosis. The third cell is isotonic, and the solution maintains equilibrium. Were you able to label each diagram correctly? I am sure you did an excellent job. That brings us to the end of our lesson. Today, we learned about isotonic, hypotonic, and hypertonic solutions. We discussed the characteristic of each of the solutions and learned how they affect the cell. Until next time, thank you, teacher. Thank you, students.